Hi class, let's discuss what are being inherited in the inheritance situation in terms of members and special functions. So all members are being inherited, otherwise there really is no reason to do this inheritance thing. But for functions, actually only the normal public member functions are being inherited, because if you think about the case of constructor, for example, just inheriting the constructor from your parents' class doesn't really work in a way, because usually you would add more member variables to your class, to your new class, and so you will have to do something with the new members anyways, right? What are not being inherited? Like I said, constructors, but also copy constructor, assignment operator that's being overloaded or not, destructor, and any private member functions are not inherited. For the case of private member functions, in the case, well, there's nothing you can do about this. Basically, you lost access to these private member functions. However, for the constructor, copy constructor, assignment operator, and destructor, you would, as a good practice, you would definitely want to re-implement them, especially constructors, right? Destructors are called automatically. It's just the way things has been, not even in the uh, in the example of, or in the case of having been inherited from anyone. But for the case where inheritance happened, the destructor of the classes are being called from the youngest class first. And so in our example of the square rectangle shape, square class destructor is being called before rectangles, and before and then the shapes destructor is being called. So basically the idea is to make sure that the allocation of memory happens, right? That's the bottom line. And so if you are not using any dynamic variables, this actually, you don't have to declare or define or implement your own destructors. But if you do, we have to make sure that the allocation of memory works. In terms of constructors, even though default constructors are actually called automatically, and in the order that is reversed compared to destructors, because the shapes constructor, the default constructor is being called, and then rectangle and then square. But in a way, this information doesn't really help you, because what we want to do is to not depend on this mechanism. What we want to do is to make sure that appropriate initialization happens in all the constructors, right? So usually we would have to initialize at least the new members that we add, if we do. And then we want to initialize certain variables that our ancestors has. So what we will do is to use initialization list. We've not officially looked at this, but we've used this already. And I think if you probably know, or you've seen this, that we are using a colon to start the initialization list after the definition of the constructor. So after this colon, we will we can call our ancestors constructor like we are doing here. We would pass in the value of the area to initialize our the shape, And then we would initialize basically the length and the width. That is the new members that's being added to the rectangle. And then in the case of square, it's pretty simple. We only pass in as the parameter the value of L, which is the name, which is the value of this length of the side of the square. All sizes are the same. And then what we do is we use the initialization list and basically just call the constructor for the rectangle passing in L and L. And then we don't, because in the case of square there is no new members. So maybe to just show you the class definition again, you can see that we have this constructor for shape that we initialize the value of area. And then in the case of parents, we have this constructor, we pass in the length and the width, and then like we talked about, we will initialize the area also using the initialization list. In the case of square, like we also talked about, we would pass in the length of the side of the square, and then we just call the constructor of rectangle, and we are done because we don't actually have any member variable here. Go back to that slide. So the reason of using initialization list then is twofold. One is to initialize member variables of the current class, and also to call any ancestor constructor if needed. Note that if we call the constructor of our ancestor inside the body of this constructor, for example, if we move this rectangle LL into here, it actually doesn't work the same. It's not actually initializing this object using the rectangle LL. What it does is kind of creating a new object, but then that new object will disappear because it goes out of scope. Anyways, remember to use initialization list if you want to call the constructor to initialize your grandkid class. We are not going to talk about the copy, how to implement the copy constructor again, or the assignment operator, because it's, case by case basis. In general, so there's a pattern in the destructor and the constructor, and that's why we mentioned it. So the other things that's being inherited are all the members of the base class. So if it's private though, you have to know that you cannot access it from the child class directly. You have to use assessors or modifiers to assess those members. However, if you have those member variables being declared as protected instead of private, then you can use dot operator to access those member variables directly. So any member variables of the family basically can be accessed using the dot operator. However, it will behave like private for everyone else. So to recap what we talked about in this video, we talked about what are and are not inherited. We talked about how to implement constructors using initialization list. We discussed implementing destructor, and then we also talk about the new keyword protected. What is protected member variables. Next video, then we finally can look at the normal functions that can be or that are inherited, and talk a little bit more about the details about how to use them and so on. We'll see you in the next video.